Hello, dear student. Welcome to Gpat 2021. Let's see what are the questions that has been asked in Gpat 2021 along with the detailed explanation. So coming to the first question, the question was des-methyl diazepam is an active metabolite having an elimination half-life of more than 40 hours of all the following drug except. So question is about so des-methyl diazepam is an active metabolite of all the following drugs except which drug? Your options is chlorazepam, chlorodiazepoxide, chlorgepid, and diazepam. So desmethyl diazepam is active metabolite of all the drugs except your chlorazepam. Okay, except your chlorazepam. Let's see. So you can see from this diagram, chlordiazepoxide, chlordiazepoxide converted to desmethyl chlordiazepoxide. Okay, from desmethyl diazepam to dextromethorphan to desmethyl hydrazine, diazepam to desmethyl diazepam, parazepam to desmethyl diazepam, chlorgepid to desmethyl diazepam. But this flurazepam converted directly undergo conjugation and followed by urinary excretion. But these drugs are converted to desmethyl diazepam, which is active metabolite with longer T half, with longer T. Okay, so moving to the next question, you can see this chlorodiazepoxide removal of N oxide moiety in the molecule will lead to active metabolite of S-methyl diazepam having a half-life of 6 to 30 hours. Chlorgepid, it is considered as a prodrug and it undergo rapid decarboxylation by the acidity of the stomach to nordiazepam, which has a long half-life and undergo hepatic conversion to oxazepam. Flurazepam, an alkyl substitution as a flurazepam is oxidatively N-dealkylated to give two fluoroderivatives of N-desmethyl-diazepam. The half-life of flurazepam is around 7 hours. Half-life is around 7 hours.
Which of the following method is used for the determination of osmotic pressure? So for the determination of osmotic pressure, which of the given methods can be used? Beckmann's method, Barclay and Hartley method, Cottrell's method or Landsberger's method. So Beckmann's method and Barclay and Hartley method, Cottrell's method, Landsberger method. This Barclay and Hartley method is used for the determination of osmotic pressure, as well as we are having De Vries method and Pfeffer's method. These all three are used for the determination of osmotic pressures. While this Beckmann's method is the temperature change in the freezing point. Cottrell method, that is a boiling point method. Next we are having Landsberger method, that is used that is also related to the elevation in boiling point, and it is used for the measurement of molecular weight of solute in the by the using elevation in boiling point. So these all, like, this is for the boiling point, this is related to elevation in boiling point, this is related to the freezing point. Next we are having Barclay and Hartley method, that is used for the determination of osmotic pressure. So yes, this will be the right answer here. This is the right answer here, like Barclay and Hartley method, Pfeffer's method and De Vries method. These all are related to the osmotic pressures. Beckmann's method related to the freezing point change, that is the small change in the freezing point. Cottrell's method, that is related to the like boiling point, determination of the boiling point. Landsberger method, that is used for the determination of molecular weight of our solute by using elevation in boiling point method. Next question we are having, which is not the colligative property. So we are having four colligative properties, that is relative lowering in vapor pressure, elevation in boiling point, depression in freezing point and osmotic pressures. Now we are having depression in freezing point. Okay, all right, right. Elevation of boiling point, very true. Elevation of vapor pressure, no. After the addition of solute, we are having lowering, we are seeing like there is a lowered vapor pressure. So this can't be elevation in vapor pressure. So this is the wrong answer. Osmotic pressure, yes, osmotic pressure is also the right answer. And the colligative property is the property of those solution that is determined by the concentration of our solutes, the weight of solutes, quantity of solute, not a colligative property. So this R is not a colligative property, R only. So D is the right answer. D will be the right answer of this question. Colligative property, these are defined as one which depends on the number of particle of solution and not on the way or the size or chemical nature of the particles. Okay, RLVP, boiling point elevation, freezing point depression and osmotic pressure, these four are the properties of, you can say, colligative properties.
Moving to the next question, substitution of constant constant for meta-benzoic acid. Okay, substitution constant for beta-benzoic acid. Your let's see, this is explained according to the Hamilton constant. Okay, Hamilton substitution constant. So according to this, the Hamilton substitution constant basically measures the electron withdrawing or electron donating ability of a substitution, has been determined by measuring the dissociation of series of substituted of benzoic acid as comparison to the dissociation of benzoic acid itself. So what it is telling that, so Hamilton substitution constant or sigma is basically indicating the electron withdrawing or electron donating ability of a substitution by measuring what? By measuring the dissociation series of a substitute benzoic acid as comparison to the dissociation of benzoic acid itself. The Hamilton constant sigma m of a particular substitution by defined by following equation is log km by kh is equal to log k minus log kh. Okay. Uh, the Hamilton constant basically taken into account for both resonance as well as for the inductive effect. So with this Hamilton constant considering both resonance of a compound as well as the inductive effect on that particular compound. Okay. So thus the metabenzoic acid symbol substitution with the constant sigma. Okay. So the sigma m is the correct answer.
Next question we are having, which of the following is not an intensive property? Not an intensive property. Intensive property are those properties that are related, that are not dependent on the quantity of substance. They just depend on the nature of, or nature of the substance, you can simply say, like, yes. So concentration, yes, this is nature dependent. Density, nature dependent. Pressure, nature dependent. But volume, this depends on the quantity. More quantity, more volume. Low quantity, lower volume. So this is a extensive property. Volume is a extensive property. Okay, this will be our extensive property. So D is not an intensive property. Volume is not an intensive property. Okay, intensity, intensive property are which depends on, not depend on the quantity of matter. This are not dependent on the quantity of matters, while extensive depends on the quantity of matters. Okay, pressure, temperature, density, surface tension, concentration, these all are intensive properties, while volume, number of moles, enthalpy, entropy, Gibbs energy, these all are extensive properties.
Next question. A diuretic compound cyclothiazide has dash or has what substitution at C3 position of 1,2,4 benzothiazide nucleus. So it is talking about what is basically present on the third carbon of a benzothiazide molecule. If you will see the structure first, you will able to understand. If you will see the structure, cyclothiazide. In the cyclothiazide, in the second position, you are finding 5 boronine 2L, 5 boronine, क्योंकि the nomenclature will be start from the bridgehead. So one, the one, sorry, this is the position number 1, 2, 3, 4, 5, 6, 7. So in the second position, you will have a say, substitution of boron ring. Okay. So that's why it is called as 5 boronyl 2L. Okay. So the substitution at C3 position is 5, sorry, 5 norbornene 2L. The correct answer is option number B, 5 norbornene 2L. Okay, at present of cyclothiazide C3 Moving to the next question. Next is, which among the following drug on standing in a aqueous solution can dimerize to 2,5-bis aminoxymethyl 3,6-diketopiperazine? So it is telling that which of the following drug will stand in aqueous solution as a dimerized form. Okay, option are pyrazinamide, ethionamide, diethyl carbamazine, या cycloserine. So the correct answer is cycloserine. Okay, because this chemically cycloserine is a 4-amino 3-isoxazoline dione derivative. Okay, the cycloserine is an antibiotic that basically isolated from the Streptomyces species such as Streptomyces orichadeus, Streptomyces garifalus, and Streptomyces lavandulus. So it is stable in alkaline but unstable in acidic solution. That's why the compound slowly dimerized to the 2,5-bis aminomethoxy 3,6-diketopiperazine. Okay, so the correct answer here is your cycloserine. This is an antibiotic obtained from Streptomyces species. Moving to the next question, the compound 2, 5, 8, 11, 14, 17, 20, 23 nona octazone 8 while para-butyl aminobenzoate, usually known for its which activity? Okay, antifungal activity, antitussive activity, or this is a vitamin, or this is a corticoid. So for sure it is not a corticoid. Okay, so what will be the other options? So vitamin, in this vitamin you have not seen such type of structure. So the correct answer will be from the antifungal or antitussive. So if you will see the structure, you will able to answer this question. So the IUPAC name of this is benzonatate. Benzoate is having a antitussive activity. So the correct answer out here will be antitussive effect. The drug name, so this is a benzoate, so it's IUPAC name. So the structure having para-butyl aminobenzoate. It is basically a centrally acting antitussive. It is basically a centrally acting antitussive effect. So its starting material for synthesis is ethyl para-butyl aminobenzoate along with polyethylene glycol monoethylene. Okay. So this is a central antitussive agent.
Next question we are having silver nitrate, that is AgNO3. AgNO3 is used for the limit test of Indian pharmacopoeia. So lead, iron, chloride or mercury. Now this AgNO3 when reacts with Cl minus gives AgCl, and this AgNO3 reacts in presence of diluted HNO3. So this is used for the case of chloride. The limit test of chloride uses AgNO3. Lead uses diphenyl thiocarbazone. Iron uses thioglycolic acid, and mercury, no, mercury is not related to a specific something. These are a heavy metal. This will be used by the heavy metals. So C is the right answer of our question. That is chloride uses AgNO3. C will be the right answer. Okay, so iron uses thioglycolic acid and we are getting ferrous thioglycolate complex, that is purple colored complex. We are having chloride that is uses AgNO3 and dilute HNO3 to give AgCl precipitate. For the sulfate we use barium chloride or barium sulfate reagent and we are getting barium sulfate. For the arsenic that uses Gudget apparatus, and here we use mercury chloride paper and the yellow color stain gives our limit test. Formaldehyde, that is this one, reacts with Grignard reagent, let's suppose RMgX, gives what? So this R basically adds to this position, so H, OH, alcohol, R and H. Primary alcohol, secondary alcohol, tertiary or quaternary. So formaldehyde always reduces into primary alcohol. If we are having formaldehyde, this will be always giving primary alcohol. When we are having aldehydes other than formaldehyde, then we are having 2-degree alcohol reduction into, and when we are having ketone, they will be reducing to tertiary alcohol. So ketones reduces into tertiary alcohol. The secondary alcohol, they are aldehydes except formaldehyde. Aldehyde except formaldehyde, aldehyde except HCHO, and HCHO will be reduced to primary alcohol. So yes, A is the right answer. And the Grignard reagent is a addition kind of reaction or nucleophilic addition reaction. They follow a nucleophilic addition reactions when reacts with the carbonyl compounds. Pyridine, we are having pyridine. So this is our pyridine. When hydrogenation, upon hydrogenation in presence of platinum, at 25 degrees centigrade and 3 atmospheric pressure, gives what they are going to How? So when we react this, we end up getting piperidine. We end up getting piperidine. So this is a hydrogenation reaction of pyridine in which hydrogenation occurs and we are getting pyridine converted into piperidine, the saturated form of pyridine, the saturated form of our pyridine. So this will be the right answer. Okay. Next we are having halogenation, that is a electrophilic substitution reaction of pyridine occurs at third position only under high pressure, only under high temperature, very high temperature, not under the normal conditions. Okay.
Next question. Which of the following drugs belongs to the class antibiotic called ansamycin? Okay, your options is rifampicin, streptomycin, azithromycin, yeah, streptozotocin. So streptozotocin is basically not, it is not an antibiotic, it is basically a compound which having beta cell destruction ability. Extraction ability. So it's have the potency to destroy the beta cells. That's why cephalosporin is basically used to model, induce model of diabetes. Okay. Azithromycin, this is a which class of antibiotic? This is a macrolide antibiotic. Streptomycin is a which type of antibiotic? Streptomycin is a aminoglycoside. And the rifampicin are basically called as ansamycin. Okay, so rifampicin, ansamycin means group of antibiotic which contains macrocyclic ring bridge cross to two non-adjacent position of a aromatic nucleus. The term ansa means handle, which describes that uh, the well topographically to the structure. Rifampicin belongs to the class ansamycin. Okay, the correct answer is rifampicin. And streptomycin, this is a aminoglycosidic um, antibiotic which obtained from the Streptomyces gracius, which is used extensively in case of uh, different type of condition like tuberculosis. Streptozotocin, this is a or streptozotocin is a naturally occurring alkylating anti-neoplastic agent that is particularly toxic to the insulin-producing beta cell of the pancreas. Azithromycin, so this is the azolide congener of erythromycin, having extended spectrum of activity, improves pharmacokinetics, better tolerability, and drug interaction profile. Next question. The dehydration of aldol product of 2-acetaldehyde molecule through a E1 mechanism occurs the formation of, okay, the dehydration of aldol products of 2-acetaldehyde. So acetaldehyde means this structure. This is acetaldehyde. So when this undergo this aldol type of reaction, what will produce? It will produce 2-butanol. Okay, how it will produce? Let's see from the chemical reaction. Okay, so the E1CB, that is unimolecular conjugate base elimination reaction. So if beta hydrogen is strongly acidic and the halide ions is poorly big group, then E1CB mechanism will operate. So question can be asked, at what condition your E1CB, that is your unimolecular conjugated base elimination reaction carried out? When beta hydrogen is strongly acidic and halide ion is poorly big group. So that will be involve E1CB reaction. So, so if we'll solve this reaction, and then first step consisting of removal of proton by the base to form carbanion, and carbanion loss its leaving group to give a alkene. So final product will be alkene will be formed. And which alkene product? It will be for it will be produced butanol. So what is the position of the butanol? 2-butanol. That means second position you will have a double bond. Okay. So this is the correct answer. So you have to remember. So how see the aldol condensation reaction takes place? Then 2-acetaldehyde aldol condition can be organic reaction. When 2-acetaldehyde react with a hydroxyl ion, there will be a formation of initial aldol. When there will be a hydrolysis in the presence of heat, it will form butanal or butanal 2-butanal. So the product is a alkene. You will be going to get a alkene.
Four membered fully saturated heterocyclic containing one oxygen, four member, fully saturated. What is the name of this ring? So we are having oxygen, so oxa. It's a four member ring. So for four member we use ET, and since it's a saturated one, so we are getting ane. So this is oxetane. Oxetane. So where is oxetane? So we are having oxetane. Yes, D is the right answer. D will be the right answer here. D will be the right answer here. So for the heteroatoms, we use oxa for oxygen, thia for sulfur, selenium, selena, nitrogen having aza, phosphorus having phosphor, silicon having sila, boron having bora. For the ring sizes, we use just for 3 member we use IR, 4 we use ET, 5 OL, 6 IN, 7 EP, 8 OC, 9 ON and 10 EC. Simply you can also learn by having it, all, in, ip, ok, on, ic. Erytolin hypoconic. And for the saturated, if it is having nitrogen, saturated 3, 4, 5 member will be ending adene, and rest we are having ane as the ending. For the unsaturated case, we are having for the 4, 5, 6 member, the ending will be having just E, and for other we are having ending as INE. So oxirane, oxygen having 3 member ring and saturation, so oxirane, oxetane, oxolane, thiirane, thietane, thiolane. For nitrogen, the saturated will be ending with 3, 4, 5 member rings, idene, aza, IR, idene, aziridine, azetidine, azolidine. Okay, so this is the nomenclature system that is also known as Hans-Widman nomenclature system.
Okay. So moving to the next question. Which among the following cation has the lowest molecular ionic conductivity in water at infinite dilution and at 25 degrees centigrade? So here you have two criteria. One is 25 degrees centigrade. The temperature of the water will be 25 degrees centigrade, and lower molecular ionic conductivity in water. So which cation will show such type of activity? Your option is hydrogen ion, lithium ion, sodium ion, or silver ion. So which among have the low ionic conductivity? The correct answer will be lithium ion. Why lithium ion? Let's see. So if you see the conductivity, so lithium ion having the least conductivity of 39. Okay. So the lithium has the lowest molecular ionic conductivity, while hydrogen ion has the highest. Highest is hydrogen ion. Okay. So increasing order of ionic conductivity is below. Hydrogen ion is highest, then silver ion, then sodium ion, and the list is your lithium ion. Please note this table. You can get such type of question in your exam. So question about ionic conductivity.
Formation of pyranose structure, that is a cycloglucose. That is cycloglucose. The glucose structure can be converted from cyclic to chain and chain to cyclic. This is known as mutarotation. Structure from glucose leads to the formation of diastereoisomers that are known as. So the cycloglucose are having alpha beta anomers, that is known as anomers. Alpha beta form. So anomers, they are anomers. Epimers is related to the glucose, related to galactose and mannose. So C2 is related to the mannose, C2 epimer, and C4 epimer of glucose is galactose. Galactose is having C4 epimerizations, epimer with glucose. Mannose is having C2 epimer with glucose. Okay, they are not tautomers and not mentamers. They both are structural or constitutional isomers. So yes, anomers, that is alpha and beta forms. Alpha beta anomers is the right answer. They will be having alpha and beta forms. They are having alpha and beta forms. Okay, so OH is present on the downward side, it's alpha. If OH is on the upward side, that will be beta form. The effect of activation or deactivation of an incoming functional group to an aromatic compound is strongest at only ortho, only meta, only para, both ortho and para. So the effect of substitution, effect of incoming group, Effect of incoming group will be only decided by the already present substituent, and the effect of that substituents will be only taking place at either ortho or para positions. There is no any effect of that particular substituents on the meta position, so they will be having effect on the ortho and para positions. The incoming group can be having either attaching to the ortho or para positions due to higher electron density, or if they are having not electron density, then it is going to the meta positions. So electron increase in electron density or decrease in electron density via some already present substituents will be happening only at the ortho and para positions. Okay, so these are some groups like ortho para directors that are having increase in electron density on the ortho para, and the meta directors that are having a decrease in electron density at the ortho and para positions.
Which among the following is orally active testosterone derivative have progesterone activity? Okay, so it is question is oral active testosterone derivative, but it should have a progesterone activity. Your option is oxymestron, dihydrotestosterone, ethylestrone, yeah, normegestrol. So it is a orally active testosterone derivative, and second is it have a progesterone activity. The correct answer is ethisterone. So ethisterone is a orally active testosterone derivative with a progesterone activity. Testosterone derivative like ethisterone, norgestrol, and ethyl that can be given administered orally. But this is, however, ethistione has a greater progesterone activity than the androgenic activity. It is having more estrogenic activity, progesterone activity as comparison to the androgen activity. Okay, so this discovery of this potent progestin activity of 7-ethyl testosterone or estrone and 19 progesterone prescribed proceed with the development of this potent progesterone. Okay, so these are rich in electron density ethynyl group and absence in 19 methyl group, which greatly enhance the progestin activity.
One of the following functional group makes benzoic acid weaker. So the benzoic acid, we are having benzoic acid, that is the COOH, converted into benzoate, benzoate and H plus. So better stabilize the benzoate ion is more acidic it is, while the decrease in stability of this benzoate leads to the weakening of benzoic acid. The plus M nature groups, plus M nature destabilizes, thus decreasing the stability. My bad, also you can say that they decreases acidity. So what are the plus M groups? So nitro, this is minus M. Chloro, that is having minus M, plus M, but since it's a halogen, it will be having higher and very higher inductive, that is minus I. Acetyl will be having minus M. So hydroxy, that is OH, will be having plus M nature group. So this will be leading to the weakening of benzoic acid, that is OH group. OH will be leading to the decrease in acidic strength of the benzoic acid. An epoxy ring can be prepared by, so the epoxy ring, that is DCC oxidation of alcohol, Prevost reaction, Dargen's glycidic ester synthesis or Swan oxidation. So this is Dargen's glycidic ester synthesis. This is Dargen's glycidic ester synthesis in which an epoxy ring can be prepared. Epoxy ring can be prepared. We are having ketone or aldehyde reacts with alpha halo ketone, alpha halo ester, alpha halo ester. We end up getting alpha beta epoxy ester.
Next question is amine group protection during peptide synthesis. Okay, amine group amine group protection during peptide synthesis can be accompanied by converting the amine to 9-fluoromethyl carbamate, 1,3-dithiene, tetrahydropropyl ether, or dimethyl acetal. So the question is amine group protection during peptide synthesis. Which of the following amino group will act as a protecting group during the protein synthesis? Okay, if you see the option, so the here the correct answer will be 9-fluoromethyl carbamate. Why 9-fluoromethyl carbamate? Let's see the explanation. So the protecting group means what? So protecting group is a molecular network that basically introduce one of the specific functional group in a polyfunctional molecule to block its reactivity under the condition needed to make the modification. You can see this is a pre-functional group. When we add a protecting group, makes the functional group unreactive. So this protecting group basically making a compound unreactive. Okay, the most common functional group that requires to protection as a aldehyde group, alcohol group, ketone group, amine, carboxylic acid. So amine should protect due to following reason. Why amine is a better protecting group? This is due to amine contains a acidic protein which can be protected by a strong base. Second point is it acts as a nucleophilic site, okay, which when may react with electrophiles. So the conversion of amine to 9-chloromethyl carbamate will act as a protecting compound. Okay, you can see from the reaction. So the compound when react with glycine, it will form this 9-chloromethyl methyl carbamate. Okay, one and you in your option. One option is there 1,3-diethine. 1,3-diethine, this is a protecting group for carbonyl compound. And tetrahydropyranether protecting group for alcohol. Okay, you can also remember question, you can see from question from these options as well.
Alpha beta epoxy ester. In Meier's theory of supersaturation, solubility chart displays the profile of curve with positive and very low slope in KNO3, NaCl, MnSO4, none of the above. So it is NaCl, that is sodium chloride. That is sodium chloride. So yes, B is the right answer. B is the right answer. Meier's theory and Isaac proposed a theory explaining the relationship between supersaturation and spontaneous crystallization. Meier's theory points that the greater the degree of supersaturation, the more chances is of nuclei formation. If the supersaturation passes a certain range of values, nuclei formation is extremely rapid, and positive and very low slope is for NaCl, positive slope for NH4Cl, KCl, negative slope for MnSO4. MnSO4 is having negative slope, positive slope at early rise in temperature followed by negative slope, that is Na and SO2. Na and SO2. Which of the following is a half reaction? Half reaction that is having either reduction or oxidation only. So this is having zinc, it's getting loss of electron, that is oxidation. Copper is gaining electrons, so this is reduction. So this is a full reaction. It's the complete reaction in which this process is having. That is loss of electron, that is having oxidation, reduction, gain of electron. Next we are having H plus OH minus, that is H2O. This is not a reaction half or full. Ag plus gains electron to get Ag neutral. So this is having a gain of electron, that is having reduction. So yes, this is a half reaction. Ag plus Cl minus, that is AgCl formation. No. So this C is the half reaction. C is having half reaction, that is having just reduction reaction. Okay. So this is having just a reduction reaction. When one of the reactants is present in such a great excess that its concentration may be considered constant or nearly so, the reaction is said to be. So if the concentration of one of the compound is in very excess, so they can be neglected, it means it's a pseudo order reaction. It's a pseudo order reaction, that is a false order reaction. So B is the right answer. B is the right answer. So for the zero order, the reaction in which whose rate is independent of concentration. For the second order, first order is one. Okay, my bad. It's a first order. First order, one in which the rate of reaction depends on the only the concentration of one reactant. Pseudo order, that is pseudo order is having the reaction in which one of the reactants is present in very large excess that they can have been neglected. The concentration of them can be neglected. So yes, pseudo order reaction.
The first question, if you observe the absorption maximum of ephedrine hydrochloride and chlorocrizol are 257 nanometer and 279 nanometer respectively. So the question is from the spectroscopy. Here they have given the A 1% 1 cm values in 0.1 molar HCl solution. Those are nothing but A 1% 1 cm. That means the specific absorbance values. In this we can say that the concentration is 1 gram per 100 ml. 1% means 1 gram per 100 ml solution. Okay, and the path length you are going to observe, that is 1 centimeter. Then only we can say that this is A 1% 1 cm. So for the two drugs they have given, for ephedrine hydrochloride it is 9.0 and 0. So at 2 nanometers, 257 nanometers as well as 279 nanometers. That means two drugs they have determined at 2 nanometers, and the A 1% 1 cm values they have given for both ephedrine hydrochloride as well as chlorocrizol. Okay. And what they have asked for chlorocrizol also, it is 20 and 105 at 257 and 279 nanometer. So for both the drugs, A 1% 1 cm values they have given. Calculate the concentration of the ephedrine hydrochloride in the batch of ephedrine hydrochloride injection, diluted 1 to 25 with water, giving the absorbance in 1 centimeter cell of 0.424 at 279 and 0.972 at 257 nanometer. Somehow a typical question it is, so which requires a little bit calculation. Let us see how we can solve this. What they have given information, that is A 1% 1 cm values at 257 and 279 nanometers for both the drugs they have given. Okay, and they are asking the concentration of the ephedrine hydrochloride in the injection. And what we need to do is, first of all, we need to determine the chlorocrizol concentration also, because it is going to give you the absorbance at both 257 and 279 nanometers. But ephedrine is giving only at the 257 nanometer. At 279 it is 0. Okay. So at 257, so first we need to correct the absorbance value for ephedrine hydrochloride. Then we can easily determine the concentration. Okay. So let us see how we can calculate this. First, chlorocrizol, because chlorocrizol is going to have both the values at both nanometer. That means ephedrine is not having any absorbance at 279 nanometer. The concentration of chlorocrizol at 279 nanometers can be determined like this. So at 279, chlorocrizol is having the absorbance of 0.424, which is having the A 1% 1 cm, that is 105. Okay. And we know that the equation, that is A equal to ABC or epsilon T into C. Anyway, you can take the equation of the Beer-Lambert's law. Okay. So nothing but A 1% 1 cm means this value is equal to absorbance value. B is nothing but 1 and C concentration we need to determine. Same thing here also we are doing. Okay. So this is the A 1% 1 cm and this is the absorbance value. So from this C, if you take out, you can calculate, that is 0.00404 gram per 100 ml, because 1% 1 cm, that means gram per 100 ml. Okay. So the concentration of the injection we need. Injection has been diluted 1 ml to the 25 ml. For that purpose, this concentration into 25 we need to do. Finally, we are getting 1 mg per ml, exactly 1.010 mg per ml. Okay, not per grams per 100 ml we got this value, but we need to convert. Okay, so 0.1010 gram per 100 ml means 1000 by 100. Okay, 2 zeros means, so into 10, automatically it will decimal shift to right side, 1.010 mg per ml solution it will come finally. That is for the chlorocrizol at 279 nanometer. Okay. Now let us see the chlorocrizol concentration at 257 nanometer. This is at 279 nanometer and this is at 257 nanometer. So 257 they have given the specific absorbance value, that is 20. Okay. And we have determined the concentration of the solution, that is C value, already we have determined. So this is 0.00404. Then you are going to get the value, that is 0.081. Okay. So if you multiply this value, then you are going to get the 0.081 value. So till here we have calculated the chlorocrizol concentration. Now we need to subtract this value from the absorbance value. What they have given, that is ephedrine concentration at 257 nanometer. They have got the absorbance value of 0.972, but at 257 chlorocrizol is also having the absorbance value, that is what we have calculated, 0.081. So we need to subtract this value. Finally, you are going to get it 0.891. This is the corrected absorbance value for ephedrine hydrochloride at 257 nanometer. Okay. And this 0.891, actually this is absorbance, corrected absorbance, So A equal to ABC. If you see that, then at 257 ephedrine is having the A value, specific absorbance value of 9.0. So from this you can calculate the concentration of the ephedrine at 257, that is 0.099 gram per 100 ml. Okay. So this is the final calculation, but what they have asked in injection, this is the gram per 100 ml total concentration, but we need to calculate for the 1 in 25 ml. Okay. So thereby you are going to calculate 0.099 into 25. So thereby you are going to get it 2.475 gram per 100 ml. Okay. So now let us see where this option is there, 2.475 gram per 100 ml. In this options, if you see, A 1 mg per ml, B 6.25 mg per ml, C 12.5 mg, D 24.75. What we got is, that is 2.475 gram per 100 ml. Okay. So if you convert that gram per 100 ml to mg per ml, automatically you are going to get 2. What we got, 2.475 gram per 100 ml, right? So if you convert this to mg per ml, what we have to do, 2.475 into 1000 divided by 100. So 2 zeros out. So into 10, if you do this value, we will get 24.75 mg per ml. So option D is the right answer. Okay. So in this way, you need to calculate the concentration of the substance if they have given in the multiple analytes also. Now let us see the second question. The total number of possible stereoisomers for 3-bromo-2-butanol. This is somehow related to the medicinal chemistry. Okay. 3-bromo-2-butanol. Okay. Options they have given 2, 4, 6, 8. First of all, let us see the structure of this 3-bromo and 2-butanol. How we can draw this 3-bromo-2-butanol. Okay. Afterwards, we will see the answer. So, calculation of the stereoisomer. We know that the formula for calculation of the stereoisomer, that is 2 power n, where n is nothing but the number of chiral centers. Okay. So, 3-bromo-2-butanol. 3-bromo-2-butanol. If you observe this 3-bromo-2-butanol structure, then you are going to see there are possibility of the 4 stereoisomers are possible. How? So, these are the enantiomers. That means if we are going to see the mirror images. Okay. So 3-bromo-2-butanol you are going to see. This is second position and third position. So enantiomers you are going to observe, this is S-R enantiomer, S-S enantiomer. Okay. And for these two, if you observe the mirror images, these are not going to be the same. So that's why you are going to observe the diastereomers of 4 types. Okay. So there are, because of the 2 chiral centers, you are going to observe 4 stereoisomers for this 3-bromo-2-butanol. So options 2, 4, 6, 8 means option B is the right answer. Okay. Now let us move to the next question. Which among the following nuclei can exhibit the NMR spectrum? Okay. What they have given, that is options silicon 28, O16, carbon 14 and 14. So by seeing the options, we know that C14 is not at all a right option. Okay, because C13 can exhibit the NMR, not C14. And if you observe this, the another 3 options, silicon, oxygen and nitrogen, we know that there is a trick to identify NMR active nucleus. That means if the mass number is divisible by 4, that means that is NMR inactive nucleus. Okay. And these two are divisible by 4. So option A, B are also not suitable. So option D is going to be the right answer. Okay. And let us see some of the other examples which are NMR active. That means actually speaking, without any tricks and all, the nucleus of an isotope, the nucleus of any isotope whose spin quantum number, that is represented as I, which is greater than the 0, definitely it is going to show the absorption in the NMR spectroscopy. Okay, so these are some of the spin quantum numbers for some of the isotopes: hydrogen H1, H2, B10, C13, it is 1 by 2. Okay, N14, if you observe, this is 1. So like this you are going to see chlorine, bromine, fluorine. So for all these you are going to observe 1 by 2 as a spin quantum number, and iodine if you see 5 by 2. Okay, so like this spin quantum number, if it is more than 0, definitely it is going to exhibit the NMR spectra, and if with this you can say that D, option D is the right answer. Okay, now let us move to the next question. The hydrogen deficiency index for a compound with molecular formula. Yeah, so hydrogen deficiency index, actually there is a formula in order to calculate this index. For any type of the molecular formula, if they have given, we can calculate the hydrogen deficiency index. Let us see first the calculation, then we will search the right option. Okay, hydrogen deficiency index, how to calculate that? The index of this hydrogen deficiency is a measure of the number of rings and bonds in a compound, which is also known as the degree of unsaturation. Okay, so this is a formula for to calculate the hydrogen deficiency index: 2C plus 2 plus n minus h minus x by 2. So what is C here? Number of carbon atoms, and what is h means? Number of hydrogen atoms, n is number of nitrogen atoms, x is number of halogens. Okay, so with this if you substitute the values, whatever the formula they have given for us, C13, so 2 into 13 plus 2 plus nitrogen, how many nitrogens are there? 2 nitrogens are there, so plus 2 minus hydrogens, how many hydrogens are there? H9, 9 hydrogens, so minus 9 minus x by 2 halogens, how many halogens are there? Only 1 bromine, so 1 by 2. Okay, so if you finally calculate this, you are going to get the answer, that is 10. So options they have given 9, 10, 13 and 8. So in this way you can select the right option, that is B here. So this is a formula to calculate the hydrogen deficiency index. Let us move to the next question. Which among the following is not a calibration parameter for UV spectrophotometer, UV visible spectrophotometer, which is not a calibration parameter? That means while calibrating we are not doing this parameter. What is that? Options they have given: control of wavelength, control of absorbance, resolution, control of transmitted radiation and spectral slit width. Okay, and they have given some of the options like A, B and D, A, B, C and E, A, B, C and E, A and B only. But actually if you see the, choose the correct answer from the options given below. They have given actually wrong option, or otherwise somehow this is a typo error for these options. Okay, let us have a look. That is, while doing the calibration of the UV visible spectrophotometer, we are doing control of wavelength by using the potassium dichromate. Okay, and control of absorbance also we are doing, resolution also we are going to check it out, as well as okay, only these three we can do. Control of transmitted radiation and spectral slit width, we are not doing the calibration. Okay, so D and E are we are not performing while doing the calibration of the UV spectrophotometer. So remaining three are the right option. Maybe there is a typo error for this.
Next question. Light directed synthesis of silica wafers is a part of bulk synthesis, combinatorial synthesis, asymmetric synthesis, and inorganic synthesis. Light directed synthesis. So light directed synthesis is a typical example of combinatorial synthesis. What is this combinatorial synthesis? So light directed synthesis of silica wafer based upon the semiconductor photolithography is a part of combinatorial synthesis. Each set of building block contains a photolabile protecting group. It is consisting of a photolabile protecting group. Once the building block which have been exposed to light can be coupled with another building block, this pattern of mass and consequence protecting group define the final structure of the compound. Example is libraries of 5,000 compound located in 50 micrometer square site. Okay, I hope you understood the explanation. So this is the questions which was asked in Gpat 2021 from the medicinal chemistry domain. I hope all of you understood what are the reason behind the correct answer.
Now let us move to the next question. A compound gives two fragments in a mass spectrometer. Two fragments we have observed. They are C19H7N plus and C19H5O plus. Okay. And to separate peaks due to these fragments, the instrument should have a resolution of. Okay. So they have got two fragments, and in order to separate these peaks, the instrument should have how much resolution they are going to ask. What are the options they have given? They cannot be separated. Option B, C, D, they have given some values. We know that there is a formula to calculate the resolution. What is that? Let us see in the mass spec. Formula to calculate the resolution, that is R equal to M1 divided by M2 minus M1. Okay, M1 divided by M2 minus M1. What is M1 here? Higher mass value, and M2 is the lower mass value. Okay, so with this, if you calculate the mass value for the two fragments, they have given the formula, that is C19H5O plus and C19H7N plus. For this, you need to calculate the molecular mass. Okay, so C19, that means 19 into carbon 12 plus 5 into hydrogen 1.00794 exactly. Okay, and oxygen only one, that is around 16, you are going to get it. And C19H7N plus, for this if you calculate 19 carbon atoms into 12 plus 7 into hydrogen atoms 1.00794 plus 1 nitrogen, that is 14.0067. So exactly if you take the values, you are going to get 249.0391 for M1 and 249.06228. Very minute difference we have observed. Okay, so if you take these two values and substitute in this formula, that is M1 divided by M2 minus M1. With this, you can calculate the resolution in the mass spec. Okay, so by seeing this, you can take the answer, that is 1.046 into 10 to the power of 4. Okay, so if you observe the options, they cannot be separated, that is a wrong statement. 2.417 into 10 to the power of minus 2, 3.402, almost all we have got the similar to this answer. So option D is the right option, and in this way you can calculate the resolving power in the mass spectrometer. Let us see the next question. The wavelength at which maximum absorption of radiation takes place. Very simple and direct, nothing but lambda max, we know that. Okay, so lambda max is going to be calculated where exactly the maximum absorbance intensity has been observed in the UV visible spectrophotometry. And next question, what will be the type of proton NMR spectrum of 2,2-dimethyl propane? 2,2-dimethyl propane. Okay, so first of all, let us draw the structure of this 2,2-dimethyl propane, then you can easily understand 2,2-dimethyl propane. In this, if you see the structure, propane means CCC 2,2-dimethyl, yeah, so second position, so 2,2-dimethyl propane, CH3CH3C. Okay, so this is the structure of 2,2-dimethyl propane. So if you observe, all the methyl groups are having the equivalent protons. So in 2,2-dimethyl propane, the protons are equivalent, so there is no splitting, and NMR signal only one singlet you are going to observe. Okay, so in the options also they have given D, singlet, so that is the right answer. So very simple, that means if you understand the structure, then it will be very simple. Now let us see the last question we have obtained from the analysis section, that is for 1,3-butadiene there are molecular orbitals of the electrons. Oh, so somehow it is related to the molecular orbitals. Okay, so in the 1,3-butadiene, how many molecular orbitals for the electrons are observed. For the electrons means actually what are the, in order to get the transitions. Okay. So, for the electrons, let us see first the orbitals, because here if you see the clear explanation, then only you can understand. 1,3-butadiene, the molecule is 1,3-butadiene. So, according to molecular orbital theory, the atomic p orbitals on each of the carbon atom are combined to form the pi molecular orbitals, right. So, for example, if you take this 1,3-butadiene, there are how many p atomic orbitals are there? 1,3-butadiene means the structure, if you see, CH2, CH, CH2, 1,3-butadiene. Okay. So, 4 atomic p orbitals you are going to observe. Automatically they are going to combine and they form the pi molecular orbital. So, 4 atomic orbitals are there, thereby you are going to see the 4 molecular orbitals also going to be observed. Okay. So, this is for your clear idea. I think this picture is visible to you. So, here just we have compared the ethylene with butadiene. So, ethylene also if you find there are 2 p orbitals are present, and if you see 1,3-butadiene there are 4 p orbitals are present. Okay. So, how many p orbitals are there? Automatically according to the molecular orbital theory, you are going to observe the same number of molecular orbital theory results also. Okay. So, with this we can say that the right option for this question, that is, because 4 p orbitals are there, you are going to see the 4 molecular orbitals also. Okay. So, these are the questions we have observed in Gpat 2021. Okay. So, thank you students, thank you for understanding. Hope you have understood the explanation for the questions. Thank you.